Welcome everyone to reInvent 2020. Let's get started. It's a little different this year. Fun fact, I am not in Vegas. I am currently in my living room, but I'm still just as excited to talk about permissions this year. So today we're going to talk about next generation permission management. My name is Bridget Johnson. I'm a senior manager in AWS Identity, and I'm pretty excited for the next 30 minutes. So this is what it looks like. First, we're going to talk about the permissions management model and how you can think about permissions as you innovate within your organization with AWS. Then we're going to go into some permission tools. I did a little Twitter survey and everybody wanted to know the tools and how they work together. So we'll do a review with that. And then we'll go into the three core parts of the permission model, which is starting with permission guardrails, embarking on least privilege, using access analysis, which is one of my favorites, and then we'll drop into a little bit of a summary on how to use attributes for fine-grained permission. And at the end, we'll do a quick recap. We do have 3 demos for you today, 1 in permission guardrails and 2 in the least privilege using access analysis. I do want to call out that today I am not going deep into JSON. There are a lot of other talks out there that are going to do that, or previous talks from the year. So no, this is going to be a little bit different than previous years. Okay, so permissions management model. And it really is a model for a journey. It's an access control journey. You're not going to get it all set on day 1. So what is driving this journey? Well, first, when you begin, you want your businesses to innovate. You want the agility to move fast. You want to give developers freedom. I hear this from customers all the time because there's so much to do in the cloud and they want to give their engineers freedom to build. But where are you going, right? And what do you want to do? And I always get this but we also want to prevent dangerous actions. We want to ensure our security posture and we want to achieve least privilege. And so you need a model that balances those two. And today we're going to explain it. So let's go. Oh, and by the way, that's Pickles on a trail ride. He pops up a few times in the presentation. Pickles the horse. All right, when we think about permissions, where do we start? I always start with who has access to what. And the who are going to be your engineers, your developers, your DevOps team, your security team, really those workforce users that are operating in AWS, and your applications. These are all of your identities. Then you have your what. You have your buckets, your secrets stored in secrets manager, your batch jobs, all of that. And what you need to do is you need to connect them together. So you have the who and the what, and right in the middle, you have the can access, and those are the permissions. And that's what we're going to talk about more today. So what does that model look like? There are 5 parts. We're going to dig into the last 3 on the screen today, but I'm going to quickly review the first 2. So first, separate your workloads using multiple accounts. And hopefully you're all working with AWS Organizations. It allows you to have multiple accounts, group them, govern them, and set controls across accounts. I would recommend that you go and check out new and latest integrations. They've been rolling out all year since the last time I talked about this, so make sure you go and check those out. Then as you have different workloads, right, in different accounts, you need to be able to access those accounts. And you need to do that with temporary credentials. And that's where federation comes in. So you want to use federation, and that's your workforce identity would assume roles in your accounts. And I do recommend that you take a look at AWS SSO for that. They're really trying to streamline that experience to get you access into those accounts. Okay, so now you've set up your accounts. You got into the account. What about the permissions? So first and foremost, you want to prevent access using permission guardrails. And sometimes I like to think about this, when you used to go bowling, or maybe you still go bowling, and you have those bumper guardrails that so your ball doesn't go in the gutter. Well, those are what your guardrails are. They just are there so nothing goes in the gutter. And that's what we'll talk about first. Then we'll talk about, because you have permission guardrails, you can actually start and have some broader permissions. And this is where you let those developers have that freedom. They don't know what services they're using yet to build. They're doing some proof of concepts. You'll start with broader permissions, but then as they roll up into production, or those systems roll up into production, you need to make sure they get to least privilege. And that's where AWS provides you tools to review and refine permissions using access analysis. And we'll go into that. That one has 2 demos, so I'm pretty pumped about that. And then finally, as you understand your permissions and what you actually need, you need a really intuitive way to set them, and so that they scale with your organization as it grows and as you add infrastructure and add individuals. And so we'll talk about fine-grained permissions using ABAC, one of my other favorite topics. Okay, so we talked about the high-level permissions model, but what are the tools that can help you implement that model in AWS? So I touched on permission guardrails, and here are some of the main tools that you can use. Service control policies with AWS Organizations. You can attach a service control policy that restricts access for all principals in and across your accounts. This includes root. So this is a very powerful guardrail. Then as you drop into the accounts, you'll have IAM permission boundaries. And what this does is it enables developers to create roles and say, oh, the roles they create have a maximum permission or must have a maximum permission. So this allows them to create and manage the permission for a role without exceeding their own permissions. We also have VPC endpoint policies. This requires that the traffic stays within your VPC. There's a ton of talks on VPCs, so please check those out to learn more. We're not going to be touching on that today. And then finally, there's block public access. You've probably heard about this with Amazon S3. It blocks existing public access and ensures that new public access is not granted for new items. Is a setting in your account or on your bucket, you can go into S3 and set it up there. So all of these that I just talked about do not grant permission. They are simply the guardrails. These are the things I don't want to happen in my organization, or I require this to be the case when somebody does an action in my organization. So what does grant access? Well, you have 2 ways to do it. You have IAM principal policies and resource policies. So the IAM principal policies are policies that are attached to a principal. That's a user or role. I'm going to use roles from here on out because you should be using roles so you can focus on temporary credentials. 2 principal policies here. One is the manage policy, and a manage policy is one where you create it once and attach it to multiple principals in your account. Inline policies are directly attached to individual roles in your account. And this is really good for like a proof of concept or something that someone has to do, maybe a little bit privileged access where you don't really want to attach it to other people. You're like, okay, you're going to go do this once. We'll create an inline policy, give you that access that you need for that, and then remove it. So you're not really reusing that permission. So that's the permission on the identities that you would grant access to. And then you have resource policies. Most famous resource policy is the S3 bucket policy. I'm sure you've all heard about. But fun fact, a IAM role trust policy is also a resource policy. And then there's a couple others in AWS. And so resource policies are really good for 2 things. First, direct cross-account access. If you are a role in account A and need to access a bucket in account B, the bucket policy can grant direct cross-account access. The other one is a little bit of delegation of permission management. So you could be somebody who says, hey, I want an engineer to own permissions to this bucket, and they could add and remove individuals or roles as needed. Okay, so those are the granting access. So you're probably asking yourself, how do these all work together, right? Because there are a lot of powerful capabilities and they need to come together because at the end of the day, the role either has allowed or denied. But, and if we were in Vegas, I would make everyone repeat it with me, but all access requests start with a deny. So unless there is an allow in one of those policies that grant access, access will be denied. And so that's something to really start with and think about when you're writing these policies. So with that being said, all access starts with a deny, but if you want to get to an allow, if you're using SCPs, the SCP must allow the request. If you're using permission boundary, so the role has a permission boundary on it, the permission boundary also must allow. Now, in the same account, the identity policy or the resource policy must allow. One or the other will do if you're working and operating within the same account. If you are in direct cross-account access, that situation I talked about with account A and account B, both the identity policy of the role and the resource policy must allow. And I was talking to a customer about this one time, and he said, you know, Bridget, it's like those hotel rooms where you have to open both doors to essentially go through. And that's exactly what that is. So both must allow. And then with roles, there is the capability that you can pass in a session policy. And that session policy is per role assumption, per session. And you can scope down access even further. And so if you have a session policy passed in, both the session policy and the policy attached to the role must allow. All right, so that was your quick review on permission tools and how they all work together. But now let's get into the meat of it. And we're going to start with permission guardrails. So first, I'm assuming that you are governing your accounts using AWS Organizations. This is a very small organization just to kind of get your mind thinking about how it might look. You have your management account. Props to the team for making the name change this year. So please start using that going forward. And then you would have separate OUs. We recommend a production development. You might have a few others as well, obviously. And in those accounts, in those OUs, I have two accounts, Pickles and Bubbles. I like to call these my areas of investment. Pickles is my horse, and spend a lot of time and some money on him. And then, of course, Bubbles, who doesn't like a nice bottle of champagne. So that's what an org looks like. But what do you want to be able to do? You want to be able to establish controls for all IAM principles across your accounts, organizational unit, and organization. And you really want to make sure that these are things that you don't want that OU to do, or you don't want that your entire organization to do. And some of the common use cases that we hear are, we want to restrict access to specific regions. That's a big one. We want to prevent everyone in the account from deleting common resources. We all know that there is a security team and they love putting in roles so they can do their checks and all those things, which makes complete sense, but you don't want someone deleting it because all of a sudden that role would go away and those checks would go away. And then restrict service actions for all IAM entities except a specific role. And this is when you're really looking at some powerful actions. Today we're going to talk about networking actions. And you would be like, okay, only a network admin should do that, and somebody who has access to the network admin role. So this is what I'm going to demo. We have a service control policy. It's going to restrict some powerful service actions. And in the demo, we'll create an SCP in the management account and attach it to the root of the organization. So that's at that top there. And then we're going to demonstrate as an admin in one of the dev OU accounts and as the network admin, and we'll see what happens. This is the policy, probably one of the few policies you're going to see today. And this basically says, deny these actions if the principal is not the network admin. Now with SCPs, what we recommend is, and you'll see in the management account, is that there'll be a default full access. Now remember, SCPs don't grant access. With that full access attached to the root organization, it basically says, go listen to the permissions within the account. When we attach this deny, if a principal trying to make one of these actions, call one of these actions, is not the network admin, then the deny will kick in and access will be restricted. And now I'm going to go into the demo where we'll be demoing this SCP in my organization. So here we go, and we will play. As you can see on the screen, this is the AWS organization account. I just went to the service control policy. I'm clicking on restrict powerful actions, and I will view it. Below, you can see the exact JSON policy that I showed you on the screen earlier with that network admin. This is my organization. I have a development and production, and you can see that full access and restrict powerful actions is both attached there on the right-hand side, and I did that to the root. Now I'm going to navigate to the development account. It's called Zombie. Why not? And I'm going to be a dev admin, and I'm changing the role right now. This means I have full permissions in the account, full admin access, and I did this on purpose so you could see the SCP kick in. And you'll see that deny. I'm trying to create an internet gateway, called it reInvent 2020, and you can see that I get an error denied message, and that is expected, right? We don't want a dev admin to be able to do that. I've now switched roles to the network admin. I'm going to try the same action to create an internet gateway. I will also call it reInvent 2020. Click create, and it works this time. And why did it work? Because the deny did not kick in, because I am the network admin role within the account. All right, moving on to the next. So we just covered SCPs, and those are guardrails across all of your accounts within the organization. Now, when you drop into the account, you may want to use permission boundaries. Permission boundaries are very powerful, and you want to enable developers to create and manage IAM roles, but control the maximum permission that they have. Now, we all know that there are engineers that love to work in the middle of the night, and you want them to be able to do that. And so you can say, hey, engineers, you can create roles, but when you create role, it must have this permission boundary. And that boundary determines the maximum permissions that role can have. And that means that they can, even if they attach an admin permission to that role using an IAM policy, the permission boundary will limit that access. I go into this in detail during the Become an IAM Policy Master talk in 60 minutes or less. So go check that out. And there's a bunch of blog posts on it too. Okay, so we've covered guardrails, but now we're going to go on to your least privilege journey. And this is one of my favorites because I love access analysis. So what does that least privilege journey look like? Well, we've started to offer tools. AWS has started to offer tools that help you review access, recognize broad access or access you did not intend, and then reduce it. And you can use these tools to find it and then reduce it confidently. So what are the tools in your toolbox? First is IAM Access Analyzer, which we'll go over in detail, but it monitors your resources and resource permissions and determines, talks about public, cross-account, cross-organization access. Then we have service and action last access, so you can go to a role and look at all the services that were used and some of the actions, especially in Amazon S3. And then if you're just wanting to clean up, which I encourage, look at role and access key last used. Anything that hasn't been used, we typically hear 90 days from customers that they're willing to remove that access, but that's up to you. Okay, so going first into using access analysis to reduce broad access. And this is just an example to get your mind going about what are the types of things that Access Analyzer would actually look for. So let's imagine there's a production account and we've got pickles in that account, and there's a bucket, probably full of apples because that's one of his favorite things, and a role. And if you look at those bucket permissions, you'll see that the pickles data processing account has access. But there's also another account from an unapproved third-party partner. Maybe it's somebody you thought you needed access to that bucket, but did not end up panning out. Then you might have a role in that account that has access for the security account to assume that role, and it's in your organization. And then there might be one for the developer account, and you're like, okay, that's a production account. I don't know if a dev account should have access to that. And so these are the things that you would see as findings in Access Analyzer, and then go and review and remediate the ones that you did not intend. So Access Analyzer looks at your resources continuously to identify public, cross-account, and cross-organization access. And these findings are very comprehensive. It actually relies on automated reasoning, which is sometimes called fancy math in Amazon. But no, in all seriousness, it uses provable security to make sure that your analysis has the highest levels of security assurance. I do recommend, there is a lot of white papers, there's some blog posts on automated reasonings, there's talks on it. If you're interested in it, it's a fun topic to dive into. But we do use automated reasoning to determine and generate findings for you to recognize your broad access. And these come up in findings in Access Analyzer, and you'll go and review. And then you can remediate or archive if it is intended. So let's see that in action. We're going to go review some broad access with Access Analyzer. And in the demo, I have already enabled IAM Access Analyzer. I'm going to review my findings. Then I'll remediate access to a bucket, something that I did not intend. That was that third-party partner, that case that I was talking about. And then we'll rescan, and then I'll go and show you some archive rules. All right, here we go. I'm in the Access Analyzer console. It's in IAM. You can see my findings, my active findings, which are here. There are 2 for the Pickles application ACC bucket. The 0 account that starts with a 0, I did not intend, so I clicked into that. Now I want to go remediate it, so I click on the link. It brings me straight to the bucket. I'm currently at the bucket in this demo account. I'm going to go to the Permissions tab. You can see that I have BPA turned on, Block Public Access. Look at the policy. Realize that that account does have access in the Principal section. I'm going to remove it because I do not want it. Then I will save the policy. Then I'm going to go back to, oh, there's the policy. Then I'll go back to IAM Access Analyzer. I'm going to rescan, and you can see that it was resolved. And so that's for a way, and now it no longer pops up in my active finding. It would pop up in resolved if I went to that account. I'm going to my archive rules. You can see I have a couple that I trust. Okay, if a finding pops up with these accounts, then that's okay, and you would go to the archive rules. But you can see them in case you ever wanted to review them. All right, so that was Access Analyzer in action. It is available for free, so you can go turn it on in your account and look at your findings. All right, so moving on, Access Analyzer right now is all about who can access what. But really, you also want to reduce access based on who did access what. And there's a couple ways to do that in AWS. You can remove unused permissions using SCPs. We actually roll up the service last access information at the account, OU, and org level. So you can go see that information. And then let's imagine you're like, I don't know if I want to use directory services. And you go see if it was used. Maybe it was, maybe it wasn't. And if it wasn't, you can add a deny in an SCP and attach it to your organization. I get to pick on directory service because my old office mate, no, we're not in the office anymore, ran that service. So I can pick on him. And then you'll want to go in and remove unused principles, services, and actions in IAM. You can see the last access date. Anything used, maybe not in 100 days or 90 days, whatever you choose, you can remove because you see the last access date. And earlier this year, we made last access information available for Amazon S3. So you can see that for all S3 management actions. And I'd like to say more on the way. Okay, so service and action last access. So you can review unused permissions with last access information, and you can remove permissions with confidence. A lot of you this year, I saw it on the news, were cleaning out your house, donated a lot of good things, and you're probably like, what are we going to do in 2021? Well, I have an idea for you. You can channel your inner Marie Kondo and do the same thing for your permissions, your roles, your access keys, and that will help you get to least privilege. So that's my recommendation this year, is to really channel that inner Marie Kondo and essentially make your IAM permission posture look like the before and after picture in this. All right, so I'm going to show you, before we get started, this is just a little bit of an example. You might have some S3 actions that are granted access to the role, and 2 were used a day ago, probably in use, probably what you need. List all my buckets, not in use, hasn't been used for a while. We would recommend removing this one. That bang should be actually one row up. And with that, list all my buckets is actually pretty powerful because you can list all the buckets in the account. So you would want to scope that down. It's a console, mainly used for console. And then you have 3 services. 2 were used, EC2 and Elastic Load Balancing, and then you have Cognito. And Cognito hasn't been used 180 days. My previous manager runs Cognito, so I get to pick on them too. All right, here's the demo for reducing access using last access information. First, I'm going to review role last used information, and then I will remove the role that hasn't been used in 90 days. I'm going to review S3 permissions and the service permissions, and I'll remove some unused permissions. All right, here we go. So I'm in the IAM console. I'm going to head over to the roles section because that's what you should mainly be using. Click on last activity. I sorted. Probably should remove the not used ones, but I really want to look at those older ones that haven't been used in a year. Probably last reInvent. And I have a test role and it hasn't been used in 354 days. So I'm going to delete that. Moving on to a role that is more in use. And that would be the dev admin role. You can see that I have EC2, S3, Elastic Load Balancing, and a Cognito access. Access Advisor will tell you all of those services that have permission, and for S3, the actions as well, and when they were last used. Okay, I saw the Cognito was not used, and I'm validating that those services match, and I'm going to detach because they were not used in the last 90 days. Now I'm going to head back over to Access Advisor because I really want to look at those S3 permissions. So I go and I click on Amazon S3, and you can see I only used 2 actions. These are management actions, and I haven't used the others. So I really want to scope that down, right? And what I'm going to do is I'm going to attach a policy that I've created called S3 Scoped, which only has those 2 actions in it, which you will see here. And you can see, looking at the JSON, because I know everybody loves it, that there's 2 actions. I attach it, and now I'm going to detach the read-only policy to get rid of all those other actions. Then I will go and head back over to Access Advisor. And you can see that the Cognito access was removed, as well as the S3. And I have very scoped permissions. All right, so now we've done the guardrails, we've gotten to least privilege or started our journey of least privilege, and now we want to use attributes for fine-grained permissions. And why would you want to do this? You want to do this so it's more intuitive, right? And also that it scales. As you add resources or as you add identities to your team, you just want a simple permission that you can say, hey, if the attributes match, which are tags in AWS, then grant permission. And this is what it looks like, right? You would have your workforce users on one side, and they would have attributes red, blue, green, and then your resources on the other, red, blue, green, and the policy in the middle will essentially say if it matches. This is the time of year where I say, hey, if you were hesitant to use tags because the service you wanted didn't support them, go check out. There's been a lot more added this year, so please go check out. You can look at the actions, resources, and conditions permissions page, my favorite page in AWS, I think, and go check out if your service has. If you haven't, message me, put comments in which ones. I will take it back to the team, but there has been progress made there, so please go look at it. And so what does ABAC do for you? It allows a permissions model that scales with innovation, right? Because I know you're all tagging things for cost allocation anyway, so you can tag with access control tags, and that means you can write permissions based on those tags. You can easily understand permissions because it says grant access if the attribute matches. You'll have granular permissions without a permission update every single time. You'll just be able to say if the tags match, oh great, a new resource was created. You don't have to go update the policy. The permission rule just applies. and then audit permissions to determine access. I do recommend you have separate tags for access control, separate tags for cost allocation, and then obviously you'll have your discovery, or what some people like to call those willy-nilly tags that just help engineers navigate their infrastructure. There is talks on this as well, so please check those out if you're looking to see the JSON policies in action. All right, and that is about it for today. So the key takeaways are, when you're going into your organization, are start with your permission guardrails, use access analysis to get towards least privilege and reduce broad access, and leverage attributes for fine-grained permission. I do want to say thank you for taking the time and watching from wherever you are in the world. It was great to talk about permissions. Please share your use cases on Twitter in the comments. Love to hear about SCPs, love to hear about any of the capabilities we talked about today, and honestly anything permissions. And so the last thing I'll leave with is please complete your survey. I do read them. I do try to improve every year. So thank you for your time, and have a great reInvent.